A 2.0 kilogram solid spherical ball with a radius of 0.20 meters rolls with an angular velocity of 5 radians per second down a street. Magneto, and I apologize for the geekiness of this, shrinks the radius of the ball down to 0.10 meters, but does not change the ball's mass and keeps it rolling. What is the new angular velocity of the ball? So we have several things to do here. We're going to start by calculating the new moment of inertia. Now the initial moment of inertia is 2/5 mr squared because it's a sphere. We plug in the radius and we get the original moment of inertia is 0.16 meter. We then shrink the ball. We have a different radius. So that comes in here, and our final moment of inertia after the shrinking is 0.004 m, and that makes sense that it's smaller because more mass is closer to the axis of rotation. Now before we take this ratio, we're going to go right to the bottom, and you'll see why in a second. We know with no external forces that I0 omega 0 equals IF omega F, and we're going to assume there's no other forces acting on this ball. We want to find the final angular velocity, which is omega F. So omega F is I0 over IF times omega 0. Now we can go back here. We wanted to ratio these, but we didn't know whether to do IF over I0 or I0 over IF. Here you can see we want I0 over IF. So we do that, we find that ratio is 4, we plug 4 right into this, I0 IF, and we get the new angular velocity is 20 radians per second.